Greetings, math fans. All right, so this is an inverse trig function worksheet. It's got every type of inverse trig function problem on it, including just finding the inverse trig of a function, and also double angle and sum and difference. It's got every type of problem on there for this chapter. All right, so it's a great example. You have all the answers in the back of the sheet. I'm just going to go through each problem, show you how I do it. If you wanted to scroll through a couple of different problems that you're confused about, just do that, but it's got every problem on it. All right, so let's kind of start here. The first problem is secant of pi over 3. Now, you guys need to understand that this is just a normal problem. This is something that you guys learned back in the day in past couple chapters. This is the inverse, or this is just not an inverse problem, it's just a secant. So if you're not comfortable with secant because it's a lot to memorize, of course you can write this as 1 over cosine of pi over 3. Remember, guys, please don't write it as cosine of 3 over pi. It doesn't make sense. You'd never take the reciprocal of a radian or an angle measure. It doesn't make sense. So you take the reciprocal of that, and of course cosine of pi over 3 is 1/2, and then the reciprocal of that is equal to 2. Okay. Same thing with this guy right here. It's negative pi over 4. So just remember, it's cotangent of pi over 4. That's equal to 1, right? And then because it's negative, it's going to be negative 1. Okay, and I guess you can look at it this way. If you want to do coterminal, you could, but we're down here. That's negative pi over 4. Cotangent is negative there. That's why it's negative 1. Okay. All right, number 3. Now we're getting to inverse trig functions. And the question you're going to ask yourselves is the sine of what is 1/2? All right, and remember the way I showed it to you. You look for there are two things you need to do, and then the third thing is you use the you think of the range. So the first thing here is going to be the sign. Of course, it's positive by looking at it. It's 1/2, and the second is the sine of what is 1/2, and of course it's pi over 6. So the answer, if you look at that, your range chart is just going to be in the first quadrant, positive. So the answer is pi over 6. Okay. Same thing with this guy here. It's the same idea. First of all, you look at the sign, it's positive. The second, you get the reference angle, which is pi over 4. And notice I'm doing everything in radians here. Okay. It's just that's what I'm doing this worksheet in. Okay. And then, of course, we're in the first quadrant, so the answer is just pi over 4. All right, number 5. It's negative, so that's the first thing. It's negative. Second is the reference angle is pi over 6. So now it's in the sine is in the fourth and first quadrant, and of course then it's going to be in the fourth quadrant because it's negative, and so it's going to be negative pi over 6. Okay. Same thing with this guy here. It's the first thing, it's negative. Second thing, the reference angle is pi over 4. And since it's, remember, cosine is going to be in these two quadrants, and now, of course, we're negative here, so we're going to say pi minus pi over 4, which is 3 pi over 4. Okay? Make sure, guys, whenever you see an inverse trig function, it's got to be in the range. I can't stress it enough. It's got to be in the range. Okay? Very important. All right, inverse secant of 1/2. Don't really know that one because I haven't really chosen to use my brain to memorize secant, but I do know cosine, so I can write this as inverse cosine of 2 over 1, or 2. All right, remember that's a ratio. You're plugging in a ratio into this and you're coming up with an angle. Just like those first two questions, you're plugging in an angle or a radian measure and you're coming up with a ratio. Now I want you guys to understand the answer to this problem, because this value right here has to be between negative 1 and 1. If it's not, okay, if a domain is not between that value, this does not exist. And so it doesn't, because it's not between negative 1 and 1. All right. Inverse cosecant of square root of 2. Again, I don't really know that very well, so I'm going to change this into the inverse sine of 1 over root 2, which is the inverse sine of root 2 over 2. And so we have positive. Second step, it's in, or the reference angle is pi over 4. So the answer to this one is pi over 4. Okay. Now this is a little bit different than 7, right? It's inverse secant of negative 2. So I can just write this as inverse cosine of negative 1/2. Okay, and then you can say it's, first thing, it's negative. Second thing, we're talking about pi over 3 as our reference angle. So it's negative pi over 3. That means it's going to be it's going to be pi minus pi over 3, or 2 pi over 3. Okay. Again, I can write this as inverse sine of, and this is again, it's one. I'll just write this negative 1 over root 2, which is inverse sine of negative root 2 over 2. So the first thing, it's negative. Second step, reference angle is pi over 4. So the answer is negative pi over 4. Okay, number 11. This is a trick question, math fans. It's a trick question because you're looking at it and going, hey, what's the sine of pi? And you're saying, oh, the sine of pi is 0. That's not what I'm looking for. I'm looking for the inverse sine of pi. So this is actually, if I kind of rewrite this, it's inverse sine of 3.14. Right? And remember, that needs to be between negative 1 and 1. So this one does not exist because you can't. You're really saying the sine of what radian measure is pi. Right? And there is no radian measure, sine of a radian measure that gives you pi. Okay? All right. Next one. Okay, this is one of the quadrantals. So you're just saying the sine of what is 1. Well, isn't it, right? Isn't it over here? Isn't the sine of pi over 2 and 1? And that's in the range. Okay, remember that. Final answer's got to be in the range. Negative 1. Okay, so right, this is 1 over here, and this is negative 1 over here for cosine. So isn't it going to be pi? And that's in the range. Beautiful. Okay, what about sine? Well, isn't sine negative 1 down here? Right? And please don't tell me it's 3 pi over 2. If you told me it's 3 pi over 2, it's wrong because it's not in the range. You just have to know that this is actually negative pi over 2. It's the way I kind of taught this when I first taught inverse trig functions. So the answer is negative pi over 2. All right, now we get into some little bit different problems here. And with these problems, math fans, what you're going to do is you got to sketch a picture. Okay, and this is the deal. This is on the inside. So it's basically the sine of some angle that I don't even know. It's the inverse cosine of 2/3, which gives me theta. That gives me an angle, and then I take the sine of that angle. So what I need to do is I need to sketch inverse cosine of 2/3, and of course it's positive, so it's here. And cosine is x over r, so this is 2, this is 3, and so it's 9 minus 4, so this is root 5. And then that's my theta here, and then I take the sine of theta, which is y over r, so it's root 5 over 3. But you got to make a sketch. Very important. Okay, so same thing here, except it's negative 2/3. That means I'm drawing it here. This dictates where it goes, guys. Okay, that means I'm in the second quadrant. If that was obviously inverse, well, we'll do some ones with numbers 17 and 18. But that dictates where it goes, and it's obviously in the first or second quadrant. In this case, it's in the second quadrant because this guy is negative here. All right, so we're going to label everything the same here. This is going to be negative 2, 3, and root 5. And then that's your theta. So I take the sine of theta is going to be y over r. So it's root 5 over 3. Happen to be the same thing. Okay, 17. Make a quick sketch here. Now we're taking the inverse sine, so we're here. And it's 2/3, so it's y over r. And this guy is going to be root 5. And then we take the cosine of theta. All right, and that's, of course, x over r, so it's root 5 over 3. And same thing with this guy right here. Sine, we're going to draw it down in this quadrant. And it's going to be negative 2 and 3 and root 5. And we take the cosine of theta. Okay, and that's going to be x over r, so root 5 over 3. Okay, so it's important to draw them that, in the correct location here. All right, number 19. Make a quick sketch. 7/3, so we're in this quadrant here, and it's y over r, so 7 and 3. Oh! Can't do that, right? That's impossible. Remember, this guy here needs to be between negative 1 and 1. And it's not. I mean, you can even look at the triangle. You can't have an r less than one of the legs. So this one does not exist. And it's not really no solution, because no solution means I'm solving for something, and I'm not solving for anything. I'm trying to simplify. I'm trying to evaluate. All right. Number 20, inverse sine of -1. So this one you got to do a little bit of work here. It's not quite as easy. If I do the inverse sine, so I'm saying the sine of what is -1. And don't you guys agree I'm down here? So this part right here is negative pi over 2. And then I'm taking the cosine of negative pi over 2. And the cosine of negative pi over 2 isn't cosine 0 here and here. So the answer to this one is 0. Okay, so that one's a little bit more work because you had a cosine and a sine there. All right, 21. It's kind of the same idea. You got to draw a picture. Okay, we got negative 2/3. Now, I could fill this in, but I want you guys to realize that I'm taking the cosine of that angle, and the answer is just negative 2/3. I don't even have to fill in that. I mean, I know it's √5, but I don't even have to fill it in if I don't want to, because this is really canceling this out. All right. Now, obviously, that's got to be in the domain. It has to be between -1 and 1 for that to work. So I come to number 22, and is that in the domain? No, it's not, because you can't have this. Again, this needs to be negative between -1 and 1, and plus, if I draw a picture, r can't be smaller than the value of y, right? So this one does not exist. All right, 23. So let's make a quick sketch here. Now, secant and cosine go together, so let's just actually do the problem the long way here and then kind of figure things out. So I'm over here. I'm at negative 2/3. This is √5. Okay, and then that's my theta. And I take the secant of that value, which, you know, it's kind of good just to know, right? Cosine is x over r, so this is r over x, right? And so if I look at it, it's just going to be 3 over -2. And that's your answer. So it's -3/2. Now you could have almost looked at it, and these are opposites, but it just flips it over. So it's just a little bit different. I don't think I'd go that route, though. I think that's just too much to know. I would probably go with the route of kind of drawing a sketch and then coming up with secant, knowing it's r over x. All right. Okay, so let's do another one here. Inverse sine, and it's -3/5, so I'm down here. And it's -3 5/5. And this is a 3, 4, 5 triangle. And then cotangent is going to be, and that's theta. So cotangent is the evil distant cousin to xy. So it's x over y. So it's going to be -4/3. So -4/3. Okay, not too bad. All right, now we start out. These are a little more challenging again because these are problems where the inverse is on the outside. Okay, and remember, I'll tell you, man, this is huge. The problems have to be in the range when you get a final answer. So if you have seen inverse cosine and you give me -pi/2 or -pi/3 or 5pi/4, if you get something out of the range, it's just, I'm going to mark it wrong and put a big R next to it because it's got to be in range. All right. Now, the beauty of a lot of these problems here, if you notice, there's inverse cosine of the cosine, inverse sine of the sine. Okay, it kind of cancels it out if it's in the range. If it's not in the range, you got to do a little bit of work. All right. So is pi/3 in the range? It sure is. The answer to this one is pi/3. Now, if you didn't want to do, let's say you weren't sure about it, you could always say, all right, this is your theta, or you're trying to find, the whole thing is your theta, and the first part here is your ratio, if you want it. Okay, and just what I did, you know, if I want to say the cosine of pi/3, the cosine of pi/3 is going to be 1/2, and then I'm doing the inverse cosine of 1/2. And remember, I told you there are 2 steps you need to follow for these kind of problems. Okay, so this is actually the more I just kind of did it the long way here, math fans. Okay, then you say, what's the inverse cosine of 1/2? Well, it's pi/3. And the way I showed you really is, the first is you tell me the sign. Okay, well, isn't cosine of pi/3 isn't over here, and isn't it positive? And isn't the second step the reference angle is pi over 3? And so then the answer is just going to be pi over 3. Got a lot of pi's over 3 here. Okay. The next problem, the answer is pi over 4. It's in the range. Okay, the next problem, 27, is it in the range? Sure is. 2 pi over 3. Next problem, 3 pi over 4 in the range? It's not. Okay, sine is between negative pi over 2 and pi over 2, so that's not in the range, so I got to do a little bit of work. First step, I got to figure out the SIGN. And that's based on all students take calculus. 3 pi over 4 is in this quadrant here. Sine is positive. Okay, that's the first thing. The second thing is super easy. That's just, oh, look at the bottom number. That's pi over 4. So the answer to this problem is pi over 4. Okay, is that in the range? Sure is. Answer is pi. Is that in the range? Nope. It's not in the range. Okay, so these actually, because they're quadrantals, they take a little bit more work, math fans. So actually what you kind of need to do here is you need to say the sine of pi is what? Well, isn't it 0? So now I'm taking the inverse sine of 0. And where else is it 0 that's in the range? Well, it's equal to 0. At 0, right? 0 degrees or 0 radians. Okay, is that in the range? No, it's not in the range. Negative pi is not in the range. But what I can do is, can I add 2 pi to that? If I wanted? I could do other things, right? I could say the inverse, I can take the cosine of negative pi and say that's going to be negative 1, and then the inverse cosine of negative 1 is going to be, pi. But just do coterminal. So my new problem is this, inverse cosine of the cosine of pi. Okay, looks familiar, doesn't it? Like number 29? Okay, so the answer is pi. Okay, is that in range? Sure is. Okay, keep going here. Is that in range? Nope. Oh man, negative pi over 5. What the heck, man? I have no idea where negative pi over 5 is. It doesn't matter. Okay, first of all, don't you guys agree negative pi over 5 is over here someplace, like around negative pi over 4, negative pi over 3, somewhere around there. So isn't all students take calculus? So doesn't that make that positive? That's your first thing you had to do. And the second thing is your reference angle is pi over 5. Okay, we're done, right? What's the answer? Pi over 5. Relatively easy schmeezy. Okay, here, negative 5 pi over 4. That's out of range. Definitely out of range. So what I can do is, if I wanted, I'm just going to deal with that negative. Negative 5 pi over 4, it's a little tricky. That's over here, actually, isn't it? Because isn't this negative pi over 2, and then negative 4 pi over 4, or negative pi? So that's negative 5 pi over 4. If you're not comfortable with that, add 2 pi to it. So add 8 pi over 4, which gives you 3 pi over 4, which still puts you in this quadrant, right? Just kind of helps you. Now you're saying, if I change that, it's the inverse sine of the sine of 3 pi over 4. It's still not in range, but let's do all students take calculus, right? Isn't sine positive here? Isn't the reference angle pi over 4? Sure is. So my answer is pi over 4. Okay, it's not bad. Let's keep going here. Brutal. Negative 13 pi over 3. What the heck is that? Well, let's do a couple coterminal things here and bring it to something that we know about. I can add, right, do you guys agree 6 pi over 3 is 2 pi? So if I add that 2 times, I could add it 2 times, right? So I can add really 12 pi over 3. That gives me inverse cosine of the cosine of negative pi over 3. That's a lot easier to work with because I know negative pi over 3 is here. And so that means with all students take calculus, it's positive. And the reference angle, of course, is pi over 3. So the answer is pi over 3. Now here's another thought for you math fans. I could have gone from this problem right here, and I could say, hey, what's cosine of negative pi over 3? Isn't cos is pos? So isn't it really inverse cosine of the cosine of pi over 3? Is that in range? Sure is. Oh, look at that. There's my answer. Okay. Here's the same thing. It's inverse sine of the sine of negative pi over 3. Right? It's same coterminal. Just add 2 pi twice. And then you can say, well, gee, I got to do a little bit of work. Ah, no, you don't. You don't have to do any work. Okay, is that in range? Sure is. The answer is negative pi over 3. Okay, 37. Ah, yes. Guys should recognize that. This is a double angle. All right? So it's got to draw a picture. It's cosine, inverse cosine of 1/2, or 1/5. So we're going to draw it, of course, it's positive, so we draw it there. And this is going to be 1, and this is going to be 5. And it's going to be 25 minus 1 is 24. So it's root 24, or 2 root 6. Okay? And then, of course, you just have to know the formula. Sine of 2 theta is equal to 2 sine theta cosine theta. Well, we got to figure out sine of theta and cosine theta for each one of these. Using the triangle. So sine is going to be y over r. So 2 root 6 over 5. That's sine of theta. And cosine of theta, that's going to be x over r, so 1/5. Now, you knew it was 1/5 because look at the original problem is inverse cosine of 1/5. So, of course, cosine of theta has got to be 1/5. Then you just multiply it all together. So 2 times 2 root 6 over 5 times 1/5. And we get 4 root 6 over 25. Okay, it's pretty easy. And here we go again, math fans. Double angle, right? And it's for cosine. So there's, first of all, let's sketch the picture here. It's 1/5, so we're over here. And it's going to be 1 and 5, and then it's going to be 2 root 6, right? Just kind of switched around from the last problem. And this is the deal. I can use one of three formulas. I can use cosine squared minus sine squared. I can use 2 cosine squared minus 1, or I can use 1 minus 2 sine squared of theta, right? One of those three. This is the deal. I'm giving you already the ratio for sine, and so why would you use anything with cosine in it? Why not use, I would use this one, 1 minus 2 sine squared of theta. Okay? Because then if you made a mistake with that 2 root 6, it's not going to cause you any grief. Okay? Obviously the number 37, you had to find both of them because you needed sine and cosine. Here, I just need one of the two, and I'm just going to use sine. So sine of theta, of course, is 1/5. So it's 1 minus 2 times 1/5 squared. All right, and that gives me 1 minus 2 times 1 over 25. So 1 minus 2 25ths, which is 23 over 25. All right. Okay, so of course you recognize this as cosine. This is cosine of A plus B. So cosine sum. All right, that's easy to recognize. You got to draw two pictures for this because you need to draw A and B. So of course sine is 3/5, so it's 3 and 5ths, and this is a 3, 4, 5. And inverse cosine, this is also positive, so it's going to be 5 and 13 and 12. Okay, so we need to figure out each one of these. Sine of A, well, that's already given, that's 3/5. Cosine of A is 4/5. And sine of B, it's going to be 12 over 13. And cosine of B is given, right? That ratio is 5 over 13. Okay, well, you know cosine of A plus B is cosine of A, cosine of B, opposite sine minus sine A, sine B. Got to know those formulas, guys. If you don't get those right, you lose really all the credit for it because you got to memorize those. Very important. All right, so let's plug it all in. That's equal to cosine A, which is 4/5, cosine B, 5/13, minus sine A, 3/5, sine B, 12/13. So that gives me 20 minus 36 over 65, and 20 minus 36 is negative 16 over 65, and that's your answer. Okay, this one here is sine of A plus B, which is sine A cosine B. That's same sign, so it's plus cosine A sine B. All right, just got to make a sketch for each one of those. Sine is 1/2, so it's got a couple radicals in here. So it's going to be 1 and 2 and root 3. Okay, and tangent is negative, and of course tangent is negative down here, and put it over 1. So it's the ox, so it's negative 3 and 1, right? And so it's going to be 9, so this is 9 plus 1, so this is going to be root 10. Okay, and let's figure out each one of these. We have sine, this is of course A, and this is B. So sine of A is really already given in your ratio here, and cosine of A is going to be root 3 over 2. And sine of B is going to be negative 3 over root 10. Now I'm going to rationalize this because really we're not going to be multiplying. Sometimes it's nice not to rationalize it because you multiply root 10 times root 10 and it just goes away. But that's not going to happen in this case. So it's negative 3 root 10 over 10. And then cosine of B is equal to 1 over root 10, which is root 10 over 10. Okay, I plugged it in, so I get sine of A, so it's 1/2 cosine of B, which is root 10 over 10, and then plus cosine of A, which is root 3 over 2, and sine of B, which is negative 3 root 10 over 10. Okay, same denominator, which is nice, so you're going to wind up getting root 10, and then minus 3 root 30 all over 20. And that's it. Can't combine them together, not same radicans, and but you can have the same denominator. Okay, so that one's it's tricky just in that it's got a lot of stuff there. It's got a lot of stuff you got to be careful about. Okay, let's do our last problem here. Now this is a little tricky because it's very similar to problems that we've done before. We take the inverse secant of the cosecant, and remember our final answer has to be in the range. Okay, so even before we start the problem, secant goes with cosine, so I know my final answer has to be between 0 and pi. That's what the final answer has to be between. Okay, it's just important just to even know that. All right, this is not as simple as before because it doesn't just cancel it out and it just makes it a little more complicated. So this is the deal. You actually have to take the cosecant of 2 pi over 3. And personally, I would convert a lot of this stuff into sines and cosines because it's a lot easier. So first of all, cosecant of 2 pi over 3, isn't that the same thing as 1 over sine of 2 pi over 3? I would go that route. And then I would say, well, what's sine of 2 pi over 3? You know, this is kind of going back to the old days and just saying, well, the reference angle is pi over 3. So what's the sine of pi over 3? Sine of pi over 3 is going to be root 3 over 2. And then, of course, since all students take calculus, it's still positive because 2 pi over 3 is in this quadrant right here, and it's positive. So this is the deal. Cosecant of 2 pi over 3 is 1 over sine of 2 pi over 3, which is 1 over square root of 3 over 2. And that gives you 2 over square root of 3, right? And so we'll rationalize that. So you get 2 root 3 over 3. And now you're taking the secant, inverse secant, of 2 root 3 over 3. Well, I know I just rationalized it. I just kind of flipped it over, but isn't it the same thing? Now, this is a ratio, math fans. That's a ratio. So can I just flip this over and say it's the same thing as the inverse cosine of that reciprocal, which is root 3 over 2? Okay, I know I didn't show my work, but I just flipped it over here. Okay, and then, well, of course, what is the inverse? So 2 steps here, right? You got to do the first one is positive. Second step is the cosine of what is root 3 over 2, and it's pi over 6. So the answer to this problem is pi over 6. That was a lot of work for that problem. But that's the answer to that final problem, because you got to do, things don't just cancel out. All right, that's it, math fans. Hopefully that helped going over at least some of these guys, and that kind of gets you ready for the test. Adios. Goodbye.